Section 2.2, Technology Systems. A system is an organized way of doing something. A system is made of parts that work together to complete a task. Systems are one of the building blocks of technology. Subsystems are smaller systems that exist within larger systems. A subsystem cannot usually function properly without its surroundings. The jet engine is one of many subsystems of an airplane. However, some systems can be both. The airplane is a distinct system, but it is also a subsystem of a transportation system. Football coaches often diagram plays to help team members understand what they are going to do during a game. Technology uses a method of diagramming, originally developed by engineers, that help people understand how any system operates. A diagram shows how one part of a system relates to the other parts. This same diagram can also help people organize plans for new ideas. When a system has no way to measure or control its product, the system is called an open-loop system. Old-fashioned bathtubs, stoves, and traffic lights are all examples of open-loop systems. These devices cannot shut down by themselves. A bathtub can overflow. A stove will stay on and burn food. A red traffic light automatically goes on even when there is no cross traffic. The open-loop system includes three parts: input, process, and output. Figure 2.2, input includes the resources, ideas, and activities that determine what we need to accomplish. For example, suppose you want to run for school president. You decide to make a campaign posters and buttons. All of the steps that lead up to the idea of creating these posters and buttons are part of input. The process is the conversion of ideas or activities into products by using machines and labor. The process of our system diagram includes designing and making our buttons and posters. Output is simply what the system produces or achieves. Your posters and buttons would be the output of your election planning. The three parts of an open-loop system diagram contain an idea, input, which leads to an action, process, which leads to an outcome, output. Can an open-loop system measure effectiveness? Could you tell if your buttons and posters accurately communicated your message to the other students? Probably not. How could you measure the effectiveness of your buttons and posters? How would you add a controlling device to regulate a traffic light? A closed-loop system is an open-loop system with an added feature that provides you with up-to-date information about your end product, output. See Figure 2.3. If students did not like your posters, what would they do? They might change them. Feedback is part of the system that measures and controls the outcomes of the system. Feedback serves as a bridge between what you want to do, input, and what you are actually doing, process. Feedback closes the loop to make the system a stable closed-loop system. Can you think of examples of closed-loop systems? The heater in a fish tank warms the water in the tank. The heater shuts off when the water reaches the right temperature. If it did not shut off, the fish might not survive. A traffic light at an intersection with built-in metal detectors can stay green for lanes that have traffic. It remains red for empty lanes. Feedback is used to open doors in some public buildings. In one system, a motion detector placed above the door senses movement in the same way that a police radar system can detect a speeding car. Some complex technological systems have many layers of feedback and control. Systems can be connected. Some buildings have computer systems that control the elevators, escalators, heating, cooling, and lighting for the entire structure. The independent systems work together as parts of a larger system.